Red Hat announced the 1.0 release of its open-source Podman project on January 17, which provides a fully featured container engine. In Podman 1.0, Red Hat has integrated multiple core security capabilities in an effort to help enable organizations run containers securely. Among the security features are rootless containers and enhanced user namespace support for better container isolation. Containers provide a way for organizations to run applications in a virtualized approach on top of an existing operating system. With the 1.0 release, Red Hat is now also positioning Podman as an alternative to the Docker engine technology for application container deployment. We felt the sum total of its features, as well as the project's performance, security and stability, made it reasonable to move to 1.0, Scott McCarty, product manager, containers, Red Hat, told eWeek. Since Podman is set to be the default container engine for the single-node use case in Red Hat Enterprise Linux 8, we wanted to make some pledges about its supportability. McCarty explained that for clusters of container nodes, the Creo technology within Red Hat OpenShift Container Platform will be the default. OpenShift Container Platform is Red Hat's distribution of the Kubernetes container orchestration platform. Red Hat has already integrated a pre-1.0 version of Podman in its commercially supported Red Hat Enterprise Linux (RHEL) 7.6 release in October 2018. McCarty said that both Red Hat Enterprise Linux 7 and Red Hat Enterprise Linux 8 will now be updated to include Podman 1.0. RHEL 8 is currently in private beta. OpenShift Creo is a Kubernetes container runtime and is at the core of Red Hat's OpenShift. Creo reached its 1.0 milestone back in October 2017. McCarty said that Podman was originally designed to be used on OpenShift nodes to help manage containers, storage under Creo, but it has grown into so much more. First and foremost, Podman is designed to be used by humans, it's easy to use and has a very intuitive command line experience, McCarty said. A user interacts with Podman at the node level. This includes finding, running, building and sharing containers on a single node. Even in clusters of thousands of container hosts, McCarty said that it's useful to have a feature-rich tool like Podman available to troubleshoot and tinker with individual nodes. One main challenge to adopting Kubernetes is the learning curve on the Kubernetes YAML, which defines running containers, McCarty said. Kubernetes YAML, yet another markup language, provides configuration information to get containers running. To help on-ramp users to Red Hat OpenShift, McCarty said that Podman has the Podman generate kube command. With that feature, a Podman user can interactively create a pod on the host, which Podman can then create and export as Kubernetes-compatible YAML. This YAML can then be used by OpenShift to create the same pod or container inside of Kubernetes, in any cluster, or even multiple times within the same cluster, stamping out many copies anywhere the application is needed, McCarty explained. The user doesn't even have to know how to write Kubernetes YAML, which is a big help for people new to the container orchestration engine. Security. One of the key attributes of Podman that Red Hat is emphasizing is the improved security. A challenge with some container deployments is that they are deployed with root access privileges, which can lead to risk. On Jan. 14, security vendor CyberArk reported one such privileged container risk on the Play with Docker community site that could have potentially enabled an attacker to gain access to the underlying hosts. With containers, the basic idea is that the running containers are supposed to be isolated, but if a user has root privileges, that isolation can potentially be bypassed. Podman has the concept of rootless containers that do not require elevated privileges to run. McCarty said that to use rootless containers, the user doesn't need to do anything special. Another key concept with Podman is that it does not require a new system daemon in order to run. Dan Walsh, consulting software engineer at Red Hat, explained that if a user is going to run a single service as a container, then having to set up another service to just run the container is a big overhead. Forcing all of your containers to run through a single daemon forces you to have a least common denominator for default security for your containers, Walsh told eWeek. By separating out the container's engines into separate tools like Rio, Builda and Podman, we can give the proper level of security for each engine. Walsh added that Podman also enables users to run each container in a separate user namespace, provide further isolation. From a security auditing perspective, he noted that the Podman top command can be used to actually reveal security information about content running within the container. Podman usage McCarthy said that Red Hat is seeing lots of usage for Podman as a replacement for the Docker engine for running containers in services on hosts. The Fedora and OpenSUSE community seem to be taking the lead on adopting Podman, according to McCarthy, but Red Hat also seen it packaged and used in many other distributions including Ubuntu, Debian, Arch, and Gentoo to name a few. Podman essentially operates at native Linux speeds, since there is no daemon getting in the way handling client-server requests, McCarthy said. Sean Michael Kerner is a senior editor at eWeekinInternetNews.com. Follow him on Twitter at TechJournalist.